Introduction. Optimization is the process of finding maximum or minimum value to solve real-world challenges effectively. It's all about determining the best maximum or worst minimum value of a quantity like cost, profit, area, volume, or time while working within a specific constraint. Let's explore how this powerful mathematical tool impact our everyday decision.
So I will explain about this question. So the question is, a rectangular door with a semi-circular top as shown in figure is to have a perimeter of 6 meter. So we need to express y in terms of x, show the area of the door, and determine the maximum area of the door. So for the first question, express y in terms of x. First, we need to use perimeter of circle and divide it to 2 because we want to find semicircular. Then find the radius, which is x over 2. We rewrite the equation and we'll get x plus 2y plus pi x over 2 equal to 6, and solve the equation to find y. So the answer we will get y equal to 12 minus 2x minus pi x over 4. For the B question, to find area, we are using xy plus pi r squared over 2. So we just substitute the information that we get from the A answer just now. So we can substitute y and r, which y is 12 minus 2x minus pi x over 4, and r is x over 2. So after we substitute the equation, we can solve the equation and we will get the answer. Area is 24x minus 4x square minus x square over 8. Alright, for the last question, to determine the maximum area of the door, we are using formula area equal to 3x minus 1 over 2x square minus 1 over 8 pi x square. So the first step is to find the derivative, which is dA over dx equal to 3 minus x minus 1 over 4 pi x. And then we need to let the derivative equal to 0. So dA over dx equal to 0. 3 minus x minus 1 over 4 pi x equal to 0. So from 3 minus x minus 1 over 4 pi x equal to 0, we need to find x. So solve the equation and we will get x equal to 1.68 meter. And then to find maximum or minimum value, we need to do a second derivative test, which is d square a over dx square. So after doing that, we will get negative 1.78. So the value is less than 0. When the value is less than 0, then the x is a maximum value. And then we substitute the value of x, which is 1.68, into the first equation, which is 24x minus 4x square minus pi x square over 8. So we will get the answer 2.52 meter square. That's all from me.
A closed rectangular box with a square base is to hold 360 cm³ of water. The material for the top and base costs RM2.50 per square centimeter, while the material for the side costs RM1.50 per square centimeter. Let X denote the side length of the square for the top and base, and Y the height of the box. Firstly, we need to calculate the cost of the top and bottom. The area of one square base is x squared. Since there are two such surfaces, top and bottom, the total area is 2x squared. Given the cost per unit area for these surfaces is RM2.50, so we need to multiply it with the 2x square, and the answer is 5x square. For the cost of the sides, there are 4 rectangular sides, each with an area x, y. Their total area is 4x1. Given the cost per unit area for these surfaces is RM1.50, so we need to multiply it with 4xy, and the answer is 6xy. From the volume equation, x squared over y equal to 360, we need to solve for y, and y equal to 360 over x squared. Then substitute at y equal to 360 over x squared into the equation 5x squared plus 6xy. And the final answer that we get is 5x squared plus 2160 over x, which is the same as the given equation. In order to find the values of x and y that will minimize the cost of the material, we need to find the first derivative first. In this question, the first derivative we got is 10x minus 2160 over x squared. Let the first derivative equal to 0 and solve for x. The answer that we got is x equal to 6 centimeter. To ensure that x equal to 6 is a minimum value, we need to do the second derivative test. The second derivative test that we got is 10 plus 4320 over x cubed. We need to substitute x equal to 6 into the second derivative test equation to check whether the answer is valid or not for the minimum value. So the answer that we got is 30, which is greater than 0, and prove that x equal to 6 cm is a minimum value. To find the y value, we need to substitute x equal to 6 into the equation x squared y equal to 360, and the value of y is 10 cm. To find the minimum cost of the box, we need to substitute x equal to 6 into the first equation, which is 5x squared plus 2160 over x. So the minimum cost that we got is RM540.
For conclusion, by choosing the right formula and accurately performing both the first and second derivative, we can confidently determine the solution, whether it's minimizing cost or maximizing outcome. This process is a versatile tool in solving practical problems, showing how mathematics can guide us to make better decisions in a real-world situation. Thank you for joining us on this journey of optimization.